Hey yo, what's up guys? Baby Bear 4812 coming at you one more time. Today with the problem that I think is really cool. It's problem 642, design search autocomplete system. So this one's more of a, I guess it's like an object-oriented design type problem as opposed to strict algorithm, though we will of course be, using some algorithms to make it work. I just want to jump in as a disclaimer before I solve this. So I had a pretty decent solution, but when I looked through the discussion, I found this post here by Yorkshire, fast and simple, explain, no try, no priority queue. So I borrowed a couple ideas from them that kind of optimized our solution. So if the code looks similar to something you've seen and you've grabbed it here, I want to give credit where it's due because it's an excellent solution and we'll be walking through parts of it today. So with that out of the way, let's have a look at this problem. Again, as always, look, if you haven't tried it, go and give it a shot yourself first. I realized I forgot to open my sketchpad. So I'll get that open. Give it a go yourself before trying it out. Let me clear this out. Let's run previous video. And all right, let's jump into it. So we need to design a search autocomplete system for a search engine. Users may input a sentence which is at least one word and end with a special character, the hashtag. So one word meaning, that one word could just be one character. That's fine. But we have at least one character, and then eventually once we see a hashtag, that means it's the end of the search. For each character they type, except hashtag, you need to return the top 3 historical hot sentences that have prefix the same as the part of the sentence already typed. Here are the specific rules. Rule 1 says the hot degree for a sentence is defined as the number of times a user has typed the exact same sentence before. Okay. The returned top 3 hot sentences should be sorted by hot degree, first one being hottest. If several of them have the same degree of hot, you need to use ASCII code order, so smaller one appears first. If less than 3 sentences exist, return as many as we can. And finally, when the input is a special character, it means the sentence ends. And in this case, we need to return an empty list. And so that special character for us will be this hashtag. I'm sorry, guys, I'm losing my voice today, so I'll try to keep this not too long. Couple functions we got to look at. First one is the constructor function. It looks like what we're given historical data in the form of sentences, which is a string array consistent of previously typed sentences, and times, which is the corresponding times or number of times a sentence has been typed. So what we will get is a bunch of sentences in one array, and then in a separate array, we'll get the frequency of each sentence, and they'll correspond. There's not going to be any funny business like different length arrays or anything. We're just going to get a one-for-one kind of mappable input. Now, the user wants to input a new sentence. The following function will provide the next characters to use. So we have to, not only do we have to fill in the constructor function, we also got to fill in the input. In this input, we're given one character at a time. Anywhere between A to Z, it'll be lowercase and blank spaces. Or again, the special character hashtag, which will cut the search off. Also, the previously typed sentence should be recorded in your system. So once we search for one sentence, we've got to make sure that we add that into our system. The output will be the top 3 historical hot sentences. So this is where we're actually outputting the top 3. We're not outputting anything here. We're not returning anything, just the void constructor function. And that seems to be it. So as an example, we're given I love you, Island, and Iron Man, and I love Leetcode. And they've each been searched 5, 3, 2, and 2 times respectively. So we can start thinking like, how do I want to represent this? If I have something and then the frequency of that something, what do we want to do with it? Right? I think you all know the answer. Now somebody begins a search, and the first thing they type is I. What we've got to do is we've got to go ahead and grab every single sentence that begins with I. Okay? So and then as we grab them, we need to check and sort them in a way where the most frequent one comes up first, and then we need to return all 3 of them. Yes, only the top 3. So every single time someone searches, we're going to be returning something, not just when they hit the hashtag. Next, somebody types in a space. So now we've got I space. Okay, this is the prefix. The only 2 options that fit it are I love you and I love Leetcode. If someone then types in I space A, we're not going to output anything because there are no sentences here that begin with I space A. And finally, with the hashtag, so once we see the hashtag, we're going to return nothing. You return null. That's fine. And yeah, that's about it. So I know this was a bit of a lengthy introduction, but the question kind of does. Here's a bit uneven. The question does kind of ask for a few things. We're told that it's not going to exceed a length of 100. It'll never be empty. We always get legitimate inputs. Please use double quotes instead of single quotes when you write tests. Okay, fine. This is administrative stuff. So it says, please remember to reset your class variables declared in class autocomplete as the variables will be persistent. What this tells us basically is somebody makes a search. Once they complete the search, clear it out, start again. Cool. All right, so let's think about this. We got I love you, Island, Iron Man, and I love Leetcode. So I think it's obvious just by looking at this. The first thing we want to do is we want to store each of these sentences as its own item, most likely in a dictionary. Okay, and we're gonna have the sentence as the key, and then the frequency as a value. I don't think as I like to say, I don't think I'm blowing anyone's mind here. Like that seems to be kind of the logical step that we would take at this point. So I want to create some sort of dictionary, and we had everyone's favorite 3 words. I love you. Debatably. Maybe not. I take that back. They're overrated. I love you 5 times. Island 3 times. Island was asked 3 times. And let's see what else we got. We got Iron Man twice and I love Leetcode. So Iron Man twice and I love Leetcode. So this was all lowercase. I love Leetcode. Cool, that was asked twice. So what do we do here? It's marked as a hard problem because I think there's one small trick to really make this thing optimal, but overall I actually don't think this will be too bad. Once we get a search, so currently there's nothing being searched. Once we start, let me even take a step back. This dictionary, I would argue, look, when we're given this information, let's initialize that in the constructor. So when we're going out and, and writing the code, I'd argue that we should save this in a dictionary, in like a history, for example. And when we save it in history, we're going to want to keep it like this in a dictionary that we can then have access to and update as needed. So one item that we're going to need to keep track of is going to be this dictionary. The second that we're going to have to keep track of is our search, right? So we're going to have a search, and every time it's this input function is called, I think it was called input right here. Every time it's called, we're going to be getting extra characters. And so originally we start with an empty string, and then we get this I, okay? And then we got to do something about, pulling these top 3, and then let's get to that in a second. Then we got a space. I can't really represent that. We do some more logic here. Then we got an A in the example. We got, maybe I'll do an L here instead, so we have at least a couple options, and so on and so forth. So 2 things we're definitely going to need to keep is going to be a search, and it's going to be this history. And so maybe I'm thinking for this video, what I'll do is I'll go between the whiteboard and the code, at least to set up the constructor. I think that would kind of make sense. So maybe I can do self.search is equal to just an empty string, and something like, we'll say self.history is equal to some default dictionary. Or even, we don't even need to get into the default dict here. Let's keep it with first principles, and we'll say for I in range and the length of, let's say, sentences, what we want to do is in the history. So in self.history, for every sentence, or for sentences of I should say, we want to set that equal to times of I, so the frequency with which it occurs. As y'all can notice, maybe I can, I could go ahead here and change this, leave the I, and then zip sentences and times together and do this through like a default dictionary, through counters maybe. I get all that. I know there's a way to do it, but I'm keeping it to first principles here. Now, let's ask ourselves, okay, at the very least, what would kind of be a brute force way of doing this? And let's say this is all I got so far. All I got was some sort of input, IL, and let's ignore the fact that we may need to run this function multiple times over, because I think that's going to be the kicker here. If I asked you to run this once, let's think about how we do that. Well, quite frankly, we would have to say, let me walk through here and say, let me look at the prefix of every single sentence. And once I look at the prefix of every single sentence, I'll say, does that sentence start with I space L? So it would for this one here, and it would for this one here. And then what we could do is we could actually pull those sentences down and say, all right, so I've got one sentence here, I've got one sentence here, and hypothetically, if we had a very large search history, we'd have more. But for now, we've got, I love you and I love Leetcode. What we could do is then store these and say, okay, my potential options are, and I'm going to abbreviate this, ILY for I love you, and that occurs 5 times. And then we would have, what was the other one? I love Leetcode, so ILL, and that occurs twice. What we would then have to do is to say, all right, let me take this array, sort it by frequency. So there are 2 things we got to do. We got to sort it by frequency, and then if frequencies are equal, and should I say decreasing. So largest frequencies first and then downwards. That's the first parameter we want to sort by. Second parameter we want to sort by, so I'll call that A. B would be alphabetically increasing. So in Python, for instance, what we can do is we can write a lambda function, and in that lambda sort function, we will sort first by frequency, descending, and then ascending by sentence. So we'd sort it by ASCII code. And that would be good, and in fact, that's actually like very close to what we will be doing. The slight difference in our implementation will be the fact that we're actually going to be getting one character at a time, and it's possible actually that as characters are coming in, we can find a more efficient way to do this. And you know, because the reason I'm saying this is, let's think about how long this would take to actually solve. If I got this character I would get every single one of these words, and I'd grab them this way. I'd grab their frequencies. I'd sort them by frequency, by ASCII, and then I'd spit out the top 3 or however many I have, right? So, and I kind of neglected this point, I glazed over it, but I think it's self-explanatory here. From this point, once I've grabbed the sentences, I have them sorted, I'm just going to pop out the first 3 from the front, not even pop them, but just return, you know, the first 3. Fine, easy enough. Say I started with the search that just contained I would do that here. I would grab I, and everything that begins with I, I'd check all them, I'd store them like this, pop out the top 3, fine. Let's say I get a space next. So this is now my search. By this method, what we do is we'd say again, all right, let me go through and check every single sentence that's prefixed with I space. Pull them all out, grab them in here, sort them the way we want to sort them, pop out the top 3, rinse and repeat, and do this every time we add a character. Is there a smarter way for us to do this? The answer is yes. So I asked that, like I'm sitting here as if you guys can answer. Well, the answer is yes, there is a smarter way for us to do this. And the key intuition here is in understanding that if I was to grab, say I start with the character I start searching with character I, and in that character I pull out all these 4 sentences. Okay, so I've got I love you, Island, Iron Man, and I love Leetcode. The next character that comes up, well, it's not like I'm going to gain any other potential candidates. Like let's say I had another word here that was I'll make up a random string here. So it's something like TSPF. Okay, if I was to now add another character to my search, I would never pick this up. Like I never began with an I. So the only thing I can do now that I've got these 4 options to work with, the only thing I've got is I've got items that I can kick off, and the items that I'm gonna be kicking off are going to be, you know, Island, and I'm going to be kicking off Iron Man because I now have I space. And when I say kicking them out, I don't really mean out of the dictionary, but you know, in this array structure that we have. So I don't need to keep doing this walkthrough every single time. The other reason I don't necessarily need to do the walkthrough is because, well, let's think about it. Let's say I take all these words, and here's one other thing. So not only am I not going to be losing items, but let's think about the following. Let's say I grabbed all these items and I had I love you, and its frequency Island, so Island, Iron Man, and I love Leetcode. So ILL. Okay. Well, look at this array here. Once I sorted this array by frequency, I don't need the frequencies anymore. Because as I keep searching, none of these frequencies are going to change. They're already sorted. So if I now see I space, I can do one linear walkthrough here, and I can only check one character at a time. How do I check one character? If my current search is I space is the second index of my search, right? It's the second index of my search. So what do I need to do? I need to check the second index of each one of these words and only keep the ones that have a space. Okay, I'm only going to check one index of every single word I found so far, not even in my entire history, but only on the first set of matches that I pulled down. So after I find my first character, I'm going to do my first set of matches that'll pull down every word or every search historically that begins with the first character. After I do that, I'm going to take those words and put them in their own array. After I sort them, of course, so I sort them. Now I've got only the words. They're fixed in this order. All right, and they're in decreasing frequency. The frequency is not going to change. After we reset our class, sure, it's going to change because maybe we add it to the history. But you know, we'll figure out how to reset that history in the code. It'll be very quick, like just to reset our search and to add it into the history. But I pull this down, my history is not going to be changing within the course of one search. So all I've got to do is I'm going to realize, okay, I don't need this and I don't need this, and all that I'm going to keep is now going to be these two. And so I can now make this a linear search every single time without pulling everything, without looking through all my history, sorting, comparing, pulling these out, and then returning the final answer. All right. So my first step is going to be, let me find every single word that begins with the first character of the search. Then I'm, sort it, pull out the words, and give me this nice format like this. Afterwards, when I'm on my second character and my third and my fourth, I'm only going to check the appropriate index of words that we've already found that match so far. We're going to drop off the ones we don't need, and all the rest of them are going to stay. Well, they're already in sorted order, actually. And so I hope that makes sense, and that's going to be our way of kind of saving time. The way we're going to do this, and we can kind of keep this, this match that we have in any given search, is I can just instantiate another, array here that's self.matches, something like this. And that'll be an array, and that'll house all of these, and we'll somehow manipulate it, again, depending on whether or not we, depending on what we're getting as our search term. The only thing I haven't really addressed yet is what happens when we get a hashtag. And so if we get a hashtag, that means it's the end of the search, and that one will be pretty self-explanatory. Once we get to the end of the search, all we're going to need to do is add that search to our history. So we're just going to add 1 to the counter. We will, once we do that, we need to clear the search, we need to clear the match, and we just need to return an empty array. So that's what we're doing when we're going to be kind of resetting this, resetting that class. So I hope that makes sense. I think at this point I want to jump into the code. Again, as I do sometimes, I've got a couple of notes open here because the code is a bit long. It's not too bad, but just a bit, and I want to make sure that I don't make any stupid mistakes and misguide you guys here. So with that said, let's have a look at what we're going to do about this input class. First thing we want to say is we want to check, and this will almost be like equivalent of error checking, and I'll just say if C is equal to, if it's equal to hashtag, meaning we've kind of gotten to the end of a search. So what I said is that within within self.history, I'm going to take my search that I have so far. So self.search, and I'm going to add 1 to its frequency. Now, what you may notice is that if I try to add 1 and it's not already in here in the dictionary, then I'm going to get an error. So for that reason, I will go ahead and change this to default dict with an integer, meaning that if an item isn't in there, and we try to do something like this, it'll throw it in there with the default of 0, and so we'll increase it by 1, and we'll always get 1 there. The next thing we want to do is want to actually reset the search. So I'll say self.search is equal to, it's going to be back to how we have it up here. And finally, I want to reset my matches. So I'm going to say self.matches is equal to an empty array, and I'm just going to return kind of null. I'm going to return nothing. So I think that's all that we've got so far. Again, I'm checking my notes here, making sure we didn't make any mistakes, and it looks like we are all bueno. Now, we said effectively that there are 2, and even before I get there, notice that this hashtag, when we get here, I'm not updating it to my search, and that's why I'm adding the search as it is, because I'm not actually adding the character until right at the end of this method, and you'll see why that is. There are then almost 2 scenarios that we need to work with. One scenario is going to be, this is my first item in my search, so I can say something like if not self.search, and so that means that I haven't actually found, like, nobody's tried to add any characters yet. This is going to be the first part of my search, and in this case, I'm going to do my walkthrough of the dictionary. I'm going to grab my items, put them in matches, sort them by frequency, descending, sort them by ASCII, ascending, and then clean out that array for only the words. Otherwise, if that's not the case, we're going to do some more stuff. And once we do this, that's when we're actually going to add the character to the search, and eventually, or once we do this, we said we're going to want to return the matches. So we're going to want to return matches. However, we're only going to want to return the top 3 results. And what we can do is we can I guess slice it up to, but not including index 3. So it'll be indices 0, 1, and 2. And at least in Python, this implementation here might depend on your language, but in Python we can do this, and this will actually return arrays of even size less than 3. So anything 0, 1, and 2 will still return. Now, what do we actually want to do here? I'm going to pull this out over here. What do I want my self.matches to equal? So I want to pull these matches down, okay? And what I want to do is as follows, is I want to say this. Here, let me do it this way, and then I'll make it cleaner into one line. What I'm going to say is I'm going to say for sentence in history. So we're going to look through that dictionary. This kind of, this dictionary over here. And I'm going to say if sentence 0, so if the first character is equal to C, then what we're going to want to do is we are going to want to say self.matches.append. What are we going to want to append? We're going to want to append an array, and that array is going to contain that word. So it's going to contain the sentence, and it's going to contain the frequency. So maybe I could do something like, well, I don't know if I can. I feel like I might mess myself up if I try to do this. So what I'll do is I'll just say, sorry, there should be self.history, and we'll say self.history, and we want the frequency of that sentence, so self.history of sentence. There's a way to do this also in one line, in case you're curious, which I do have jotted down. We could have just said self.matches is equal to, and then we could do something like sentence and frequency for sentence and frequency in self.history dot items, and we would do this only if sentence dot, I guess, starts with C or sentence 0 is equal to C. So we could do this all in one line. I'm gonna leave it like this just so it's a bit more legible. But what this will do is this will give us this kind of structure that we built out over here. Now, what I want to do with this is to actually sort it, like I said. So I'm going to say self.matches.sort, and we need to sort it using a lambda function. A lambda function because we want to define specifically how we want to go about sorting this. And the way we wanted to go about sorting it was in decreasing order by frequency. So for every kind of array, we want to sort in decreasing by the second index, or index 1, which is the frequency, and then ascending by index 0. So that'll sort it for us. And then I'm going to say that I actually just want self.matches. I'm going to use a list comprehension here, so I don't need to create a new array. I want this to equal, I guess this will be, I'll call it x now, so just the word for x in self.matches. And what this is doing is this is saying in the self.matches array, so we're kind of almost doing like a self-referencing thing. For every entry that's in there, an entry is an array with a string and a frequency, grab only the string. And so what this does is this turns I love you 5, I love Leetcode 2 into, write it out, into I love you and I love Leetcode. And notice that it's sorted. I no longer care about what the frequency is, right? All I care about is the fact that I've got the words in order. And that's all we're going to need to do there. And afterwards, we kind of return it. Now, what if we already have a search going, all right? If we already have a search going, then think about this. I've got a search, and my search so far is just the letter I, okay? So my search length is 1. I'm going to say some index I is equal to the length of self.search. Notice that I haven't added this new character on yet. So let's say my search is of length 1. It's just, you know, the letter I. Now I'm noticing here, maybe I'll make this index so I'm not confusing the letter I with the index here. The reason I'm going to set this variable index to the length of the self.search is because, again, I've got this I, I've got a length of 1. The next thing that just came in was a space. So now this variable C is just equal to space. I want to make sure that index I, of all these searches that I have so far, of I love you and I love Leetcode, are equal to space. So I want index 1 to equal a space. And so that's why I'm setting the index to the length of the search. And then we're going to do something similar to kind of what we did here. And what we'll do is we'll take self.matches, and we're only going to take the items. So for every single match in self.matches, we're going to grab that match only if the length of the match is actually greater than, let me move this up. And so there are two conditions here. If it's greater than I and if match of I is equal to C. The reason why this condition is important is as follows. What if I had an entry in the dictionary that just, you know, it was like I. That was the only search, and that had a, you know, it came up 5 times, for instance. Now we're looking for I space. Well, space isn't going to be an index 1 because index 1 doesn't exist right over here. So that's why we need to make sure that this string is actually long enough. And then if it is, we also need to make sure that within that, in this case in index 1 or the second character, that it's equal to this character that we now want to search. And that should be it. I'm going to press the run button here and see what I did. And it says that it's invalid syntax. That's because I neglected to put in the equal sign. Whoa. And I also neglected to spell in 5 sentences. I is not defined. Lovely. Let's keep going. Because I used I here in index here. There we go. All right, I'm gonna press match. Drum roll, please. Ta-da! There we go. Look at that. 97% time, 97% space. Yeah, so I think this is a wicked cool problem. I really like this one. I think the solution is very clever. I think that the brute force solution isn't too difficult to piece together. You have to store the searches. You have to keep all the history. I think grabbing the histories and their frequencies, like I don't think that's too hard. I think that's kind of intuitive. I even think that this piece over here is pretty intuitive. The piece, the part to kind of put together that stretches your brain a bit is in understanding what to do if we've already had these searches. To understand that we don't need to keep looking through the whole dictionary. That one sort will be enough. And once we do that sort, we just need to do a walkthrough and slash out the words that no longer fit what the next character is. That's it for me, guys. I hope you enjoyed. I hope you found it useful. Let me know in the comments down below what you think. Like, comment, share, subscribe, all that good stuff. And I'll see you in the next video. Peace.